All right, we have moved on to the top of page 24, and I'm going to hit a couple different examples here, and then I'm going to call it good for right now, and then we can talk about more of these on Monday when we're reviewing. Any of these are going to be good review problems because, like I was saying previously, that all of Unit 4 is working towards factoring so that we can use factoring as the method to solve these kinds of equations. So everything we're doing is gonna, if you can manage these ones at the very end, then you've covered everything that is in this Unit 4 test. But practice is going to be really important. So make sure that you are continuing to practice. Do lots of example problems, lots of work in Alex. All right, so this one on the top left here on page 24. So it is in descending order. It's already set equal to 0, so I can go ahead with factoring and see if I have a greatest common factor in this case. I notice they are all even, so I do have a greatest common factor of 2. So I can start off by pulling that 2 out. Noticing if I multiplied back through with that 2, I would get back to where I had started. Now the 2 at this point, because it is not a variable, and if you imagine dividing this whole thing by 2, would divide out, and then this will just be 0, we can just ignore it. And that is because it is a constant GCF. It's only a number. It does not have a variable part on that GCF. And because of that, we can basically just toss it and say the answers are going to be the same as if we were finding this equation. Finding the answers to this equation will be the same. And that is the whole idea behind solving equations, is that we are using logical steps with our algebra to keep the equation meaning the same every time, but making it more simple so that we can figure out what the solutions are. All right, so now we have this trinomial, and it's always a good idea to check and see, is this a perfect square trinomial? All right, so this t squared, so the square root of that would be t. 25, the square root of that is 5. So that would give me 5t, and then if I multiply by 2, I'm looking for 10t as my middle term, which is what I have. So it is a perfect square trinomial. So I'm going to take those two square roots that I came up with, and it'll be, sorry, I didn't mean to put the operation in there yet. It's going to look like that, and then these are actually both going to be addition, because we know it's a repeated term. It's this one squared, and then we use addition because that is the operation in front of the 10t. And again, if you are able to, catch these, then it does make this process a little easier. If not, you can go off to the side and factor 25. There still aren't that many factor pairs for 25, so it should come up fairly quickly that you would want to use 5 and 5 to get the appropriate middle term. And then now I have 0 set equal to a bunch of things multiplied together. So set each of those equal to 0. Of course, it is the same term, so it is the same binomial, so we know we're going to get -5 for both of these. And then it's a matter of going back, and again, going back to the very top, the original equation. So to the 0 equals 2t squared plus 20t plus 50, and plugging the -5 in there to verify that it is, in fact, a solution. So will this be it if I put -5 in here? And this will get us 2 times 25 minus 100 plus 50. So that would be 50 minus 100 plus 50. So yeah, we are going to get, when you clean that up, it will be 0 equals 0. So, yep, so that repeated answer is the correct solution for that equation. All right, so I'm going to look at the one right below that. So looking at that one, t cubed minus 36t equals 0. It is in descending order. It's already set equal to 0, so I am good to start looking at my factoring checklist. Is there a GCF between those terms? And there is. There's a t I can pull from both of those. So I would have t on the outside times t squared minus 36. And don't lose the t. So here we can't lose it because it is a variable. And the one right above it, it was a 2, so it's okay. It's not going to make a difference in my final answer. So t squared minus 36, I'm now going to focus in on. It's a 2-term one, so I need to ask myself, is this a difference of squares situation? And then thinking, okay, well, the square root of t squared is t, and the square root of 36 is 6, so yeah, it is. They're subtracted, so it's a difference, and each of them is a perfect square. So that means it's going to be, remember we call those conjugates, so t plus 6 and t minus 6. So added in one set of parentheses and subtracted in the other. And because we had that t as a greatest common factor, we will actually have 3 solutions on this one. But that's fine because we were able to factor it. Now, if it was not able to be factored, then for this class we would have to stop when we hit a point where we couldn't factor any further and wait until we get to Math 100 to get a few more solving methods under our belts before we could continue. But here we can make it in a bunch of things multiplied together, set equal to 0. So we're good to go with our method here. So t equals 0, or t plus 6 equals 0, or t minus 6 equals 0. And solving, so of course, that's just t is 0, or t is negative 6, or t is positive 6. And then going back to the t cubed minus 36t equals 0 equation to test each of those quickly and make sure that they do satisfy that equation by getting a true statement when I plug those in. So 0 cubed minus 36 times 0, will that be 0? Is that going to equal 0? Well, 0 minus 0, yeah. So t equals 0 is good. Then checking negative 6. So negative 6 cubed minus 36 times negative 6. Will that one equal 0? Remember, because this is a negative with an odd power, this will be negative 216. This here will become plus 216. And you can see that that will then be 0, equaling 0. So we're all set there. And then our last one that we need to check is the positive 6. If I cubed that, and will I get 0 for that as well? So 216 minus, and of course 36 times 6 is 216. So we will get 0 equal to 0 for that as well. So back here at this step, I can put a nice box around all 3 of those answers because they will all give me true statements when I plug them back into the original equation that we started with. Okay, I'm going to flip over to the next page. And we are going to look at the one on the bottom left here on page 25. So we're on page 25 here. And I want to look at this one because we have a little work to do before we can get to the point where we can use our 0 product rule. We do need to go through and get this solved for 0. And we've got to do some distributing and things. So here we have 8h, and then we're going to distribute that 5. So we'll have 5h minus 45 plus 6. And then we're going to want to get everything on one side. So, and then here it just kind of depends on how much you would prefer to have a positive coefficient on h. So if I have that here, let's see, let me collect up my like terms here. So this will be, let's see, negative 45 plus positive 6. Okay, so that is going to be negative 39. And then I can move all of that over to the other side, or I can move the 8h over to the right. But I'm also looking at this and thinking to myself, you know what? This is a linear equation, and I don't have to get everything on one side and use the zero product rule in this situation. But let's keep moving with the zero product rule and see how that flows. Okay, so I will subtract 5h from both sides. We'll get 3h equals negative 39. And then adding 39 to both sides. Now, yes, we could go from there and solve it the way that we were used to, but I do want to just try doing the product rule, the zero product rule method on this one so you can see how it will look. So we've got 3h plus 39 equals 0. And then at this point we are going to factor. We can factor out a 3. So we get 3 times the quantity h plus 13 equals 0. Remember, because this is a numerical factor only, I can divide that out and then just have h plus 13 equals 0, which would give me h is negative 13. Yeah, it's going to be the same thing. Over here, we'd have 3h equals negative 39. Divide both sides by 3. And we will get negative 13. So either way, if it's a linear, so first degree, if it's a first degree equation, we could use either of those methods to continue on there. And then you, of course, do need to go back to the original equation, plug in that negative 13, and see if we get the same thing. All right, so 8 times negative 13. Is that going to be equal to 5 times negative 13 minus 9 plus 6? And 8 times 13 is not one that I have in my head. So let's see here. So that's going to be negative 104. Okay, and over here we're going to have 5 and times negative 22 plus 6. 5 times negative 22 will be negative 110. Plus 6, and then hopefully you can see here that that is going to give us negative 104 on both sides. So that is an acceptable, verified solution to our equation in that one. Okay, and let's see here. I think I'm going to leave it at that one for right now, and then I will put up another video with a couple more examples done, but I do need to get ready for my other class that's going on today. And I don't have enough time left in this video to do more examples. So I will leave it here for now, and then I will make a video with a couple more examples from pages 26 and 27. If there are ones in particular you'd like me to do, then please shoot me an email or a text with those so that I can make sure to address those in my next video. So, thank you again, and hopefully this will not be too terrible, and we will get any questions dealt with on Monday. Or prior to that, if you have them, please let me know or go to SI. Thanks.